So this is the multiple choice practice number 1. Number 1 is E because it's multiplying by 100. So it's taking a data set and it's timesing everything. That's not even a word. It's multiplying everything by 100. So the mean gets multiplied by 100. The median is the same. Standard deviation and max. All 4 of these will get multiplied by 100 because standard deviation is not affected by adding and subtracting, but it is affected by multiplying. Z-score is not affected because it is relative to the data. Like, so if everything gets multiplied by 100, your position amongst everyone else does not change because everyone got multiplied by 100. So the answer would be E for number 1. Do you need me to do anything else? Nope. Number 2. Anything? Questions about 2? Number 3. Number 3, the answer would be B. I think some people were confused about that in 4th period. That is because if your center is at 720, 700 and 740 will contain the most amount of data because it's about 1 standard deviation away, or it's the closest to the mean that contains it. So, yeah, by the empirical rule, it would contain the most. Number 4. Number 4 talks about brand A, but then in the actual question, it never even refers to brand A. So that's kind of just there to throw you off. Because it's saying, is there convincing evidence that brand B is greater than 1,000 hours? So is B greater than 1,000? And so the answer would be A, because we're not talking about A anymore. So you can automatically cross out anything with brand A. Number 5, I think several people missed this because, so your sample size is 100, which since it's greater than 30, we can assume it is a normal distribution. And so by that means that the center point, which is around, I guess I would say maybe 90, is about my mean. And then everything to the right and the left is about 3 standard deviations away. So there's 2 ways you could do this. You could take the max minus 90, like 120 minus 90, and divide by 3, so about 10. Or you could take this whole range, like 70 to 120. That range would be about 50, and divide it by 6 standard deviations, which is essentially like 9 point something, which the closest answer would be 10. Yes?
I think some people missed this because there was not an actual question.
Right, so this question didn't show up on the problem set, but I uploaded the PDF. So there's a... It got omitted because there was no question, but I uploaded the PDF for this next one, but I don't think there's any errors on this one. Number 6. Let's see.
I missed that one.
Okay, number 6, it says skewed to the left. So my keyword there, skewed to the left. When I have a left skew, that means I'm going to draw it as a box plot because that's kind of talking about quartiles and things like that. So a skewed left box plot would probably look something like this. And it's saying the mean is greater than the median. That is false because the mean always goes with the tail. So the mean, median, and then Q1, Q3, max, min. So if I were just to label. So not A. Median is the average of the first and third quartile. No, not the average. It's the midpoint. There are fewer selling prices between first and median than there are between median and third. That could be true, but it isn't necessarily true. Like, there's no way to know this. So while it could be true, there's no way to accurately tell because the median could be here, it could be here, here, here. We don't know where the median is relative to the first and third quartile. So we can't prove C. D, there are more selling prices that are less than the mean than selling prices greater than the mean. That is false, because since the mean is going to be less than the median, there will be less area below than there will be above, or less data points. And then D, the value of the max minus the third quartile is less than the first minus the minimum. So this value is less than this value. That is a true statement. So the answer would be E. Oh, 7. 7 is asking degrees of freedom. So that's where you do the rows minus 1 times the columns minus 1. And so we have men and women. So that's 2 columns or 2 rows. Then we have in favor, not in favor, no opinion. And then that's 3. But I subtract 1. So it'd be 1 times 2, which gives me 2.
Well, I got lucky. I just thought it was 3 minus 1.
You did get lucky because that won't always work. So it's like categories minus 1, categories minus 1. So that's how I got the 1 and the 2. Because if I had men and I had women and then I had in favor, not in favor, no opinion, it would be a 3 by 2. But you only look at the, like you take the rows minus 1 and the columns minus 1. So there's only 2. That's the way you get degrees of freedom for an independence test on a chi-square. Eight. Let me go up. So just because something is symmetric does not mean that it's normal. Normal is symmetric, but that doesn't mean symmetric is normal. All of these could potentially be true, but it's not must be true. But it is true, like when something is symmetric, by definition, the mean is equal to the median. And this is just there to throw you off. Never even heard of any such thing. Number 9 was a good one. And this is definitely a formula that you'll want to remember because it'll show up a couple times probably on the actual AP exam. So it's talking about the mean and the standard deviation of a die. And it's saying that we're flipping 2 of them. So which is the closest resulting standard deviation of the sum? So I'm combining 2 dice. So I'm combining the standard deviations. So the rule, it's not asking about the mean, but if it were, remember the rule for mean is you just add them together. So 3.5 plus 3.5 equals 7. If you're combining. The standard deviation rule is always the same, whether combining or subtracting. It is the square root of standard deviation squared plus standard deviation squared. Always. And then I think you end up getting 2.415. So even if it said what's the difference, you would still always add. Yes?
And that is the same standard deviation no matter what formula the individual standard deviation is.
Right. Number 10. Oh, okay. There's gonna be one of those on there, and I can't guarantee you like which margin of error formula it will be. But when you decide, so if it says like what is the minimum sample size, you know you're gonna be solving for n. So from there you have to decide: is it 1 or 2 samples? Is it mean or proportions? So looking at this problem, what is it? 1 or 2 samples?
Sample of children 1.
1 sample. And is it means or proportions? Mean. So it's a T.
How do you know it's mean?
Well, it gives me a standard deviation, first of all. So there would be no standard deviation in a proportion kind of problem. But it says average age right here.
Pascal's major box.
There's no standard deviations in proportions. There is just proportion. That's the only variable you look at.
So wait,
With
are there-
means, you have mean and standard deviation.
There's
Yes.
4 different formulas for margin of error.
Yep. And so,
You know all
with that, I can go to my formula chart, which I hope that you utilize. And then the margin of error is everything after the plus or minus on the confidence interval equation.
Let me obtain a formula sheet.
Page in the book.
Yes, and it's also on your mock test as well. You have one. So, margin of error equals, if you look at the formula chart, it's T star S over the square root of N. However, when you're doing a margin of error, why can we not use T star?
We don't have degrees of
Yeah, you don't have degrees of
sample
freedom.
size.
Like, you don't have sample size, so you don't have degrees of freedom. So we use a Z star instead. Now, my margin of error is 0.1. My Z star I can calculate by doing inverse norm of 0.9950 and 1. So somebody do that really quickly and tell me what you get. Then my standard deviation is 1.5 over square root of N.
It was 2.576.
Okay, perfect. From here, you're trying to solve for N. So I'm going to take 0.1, divide by 2.576, and you get something.
Why do you know
Jeremy,
that?
because I'm just dividing.
Oh, do you need me?
Yeah, will you do that for me?
Oh, wait. Oh,
0.0388.
Equals 1.5 over square root of N. Now, I want to get N by itself. So a couple things you could do. You could multiply by each side by the square root of N, and then divide by 0.0388, or you could put this over 1 and then cross multiply. Same thing.
38.65.
So the square root of N equals 38.6566.
Just
Then I'm going to square, and you get N equals, what do you do when you square it?
1,494.
1494. So when I have these options, none of them are 1494 exactly, but you're going to choose the one that is closest to it, but it is larger. So I'm not going to choose the 1300, even if that technically were closer. So even if I got 1350, I still would not choose 1300 because that's not the minimum. Yeah, because it's exceeding it. So you choose the closest one to it that doesn't exceed it. So that's why the answer is D. Well,
Like, as closely as possible.
that you choose the answer choice that exceeds what you already found.
It can't be below the minimum.
Right.
Wait, how do you know when to use Z and T, or when to use T?
For margin of error, you're always going to use Z because you will never have your sample size.
So it doesn't matter which, like whether it's means or whatever.
It wouldn't be proportions because the margin of error formula for proportions is Z star square root P 1 minus P over N.
Oh, so that's where these things come in. So
Right.
it's-
So on your formula chart on that back page, it gives you all of the standard deviations, and you're just plugging them in here.
Oh, so technically you don't have to memorize all these things. It's
Right, so margin of error formula will always be Z star, and then this is what you're interchanging with the standard deviation, and you're deciding if it's 1 or 2 sample, and then if it's T or Z, T or Z. So means or proportions. So that's what goes in this highlighted box. Okay, number 11. So this one was was trying to assess whether you know what a sampling distribution is. A sampling distribution is when you have population data. So I'm going to write population really big. So we've got population mean and standard deviation for the whole population. Then we take a little tiny sample of 400 people. So here's my sample of 400. Now we have a new mean and a new standard deviation. So So this is the data for the whole population. A sampling distribution is when you take a sample from that. And we get a new mean and a new standard deviation. The mean stays the same. The sampling, or the standard deviation, is that standard deviation divided by the square root of my sample size. So sigma over the square root of n. So that's where the 0.5 comes in. So you can automatically, looking at this, they'll never give you one this easy where it's 10 and 10. That was just there to throw you off. And the reason why you know it's normal and not skewed is because my sample size is greater than what number?
5 or
30. Means is 30.
5 is expected, something
That's-
expected.
Means is 30. Chi-square is 5. And proportions is NP is greater than 10.
30 chi is,
5.
and that's the expected value is greater than 5.
Mhm.
And then
Number 12, this is where you had to use the outlier formula. So 1.5 times the IQR. The IQR is 18 minus 15, so 3. So 4.5. And we're taking this number and we're adding it to 18 and subtracting it from 15. And,
I just clicked the wrong one.
oh,
Oh, no.
hate when that happens. So, is anything less than 10.5? No. Is anything greater than 22.5? Yeah, the max. So the max, 24 is going to be an outlier. So we get rid of A, get rid of C, get rid of D. Then we have B and E left. The answer is E because we don't know if there's any observation between 22.5 and 24. So there could be something in between those two. So there could be another outlier on the high end. But B was there to trick you. 13. What kind of test is this?
one's yes.
Put a chi-square.
Not a chi-square. This column, anytime you see a difference column, it's a match pairs.
It's always the
So if you see a difference column, go ahead and write match pairs on your paper. If they went ahead and made you a match, like a difference column, that's clear indication that is a match pairs test. So this is my mean. I'm gonna put X bar and S of my match pairs, like of the difference. So it's asking me for the p-value. A matched pairs uses what kind of test in the calculator? A one sample t-test. So I'm just going to do a t-test in the calculator. That's stat test 2. My null is always 0 because we're seeing if there is a difference or not. Then you put in your mean as negative 0.425. My S is 1.395. And then it's a less than test because we're wanting to see if the medication improves the pain. And you end up getting, I don't know, 1.1802, I think. So if you want to go back and try it in your calculator, you could. Oh, this is a good one. Okay, binomial. Anyone remember what a binomial means when I say binomial? Fixed trials. And it's like finding so it's like saying out of 20 free throws, what is the probability that you shoot or make exactly 3 of them? 3 out of 20, something like that. So N represents the number of trials. And P represents your probability of success. Now, there are like rules and graphs that we looked at in the PowerPoint that describe what happens when your probability increases and decreases. What does that do to the graph? I don't expect you to remember all of that because there's just so many details to remember. So one way you could guess this or look at the graphs and tell is that your expected value, so if I have 20 trials and my probability of success is 25%, how many would I expect to make? So if we're talking about free throws. 5. So my mean would be 5, n times p. Now, out of all 5 of these graphs, which one is centered at 5?
That one. Sorry, that was not A or C.
C. A would probably be more like down here-ish.
That's geometric, right?
It would be probably more of a geometric. So, all those go away.
Geometry.
15 talks about a double-blind experiment, and it asks why it would be impossible to conduct a double-blind.
Okay, I thought this one could be 2.
Yeah, 2 of these.
I thought it could be C
That one.
or
E.
no.
C, I think.
C or E.
Yeah.
So E could happen. Like if I'm grading your tests, so you go home and you study, and you either use flashcards or you use a computer. You turn in your test to me, and I grade. But you never told me how you studied. I could be the person that grades the test and still not know whether you used flashcards or a computer. So this one is not true. Because I think like you could be blinded by the person that grades the test could be blinded. But you as the child taking or studying for the exam, is that what we're talking about? Multiplication facts. You as the actual person doing the studying, you yourself will know which study tactic you use. Does that make sense?
So double blind was to throw us off, kind of, because it was why couldn't a blind experiment be conducted either?
Basically, like, why
Or,
could
Why
it...
can't both be blind?
Yeah.
At least one is not.
Right.
The child is only 8 years old.
And while D is a true statement, we're not measuring whether they're a boy or a girl. Like, A, B, and C is not what we're measuring. We're measuring whether they use flashcards or a computer, and that's the treatment. So that's what we care about, that they know what treatment group they're in. But E could still happen. Okay, 16. This was a good one. How do we do on that one?
Correct.
Is it? Are the 5 miles per hour not like just there to put another number?
Yeah, that doesn't even matter. So 40% will be driving more than 5 miles per hour over the speed limit.
That was
So my
P minus
probability
minus
is 0.4. And then it's saying at least 1. We've learned 2 ways to do this. We've learned 1 minus the probability of none. And then we've also learned how to do it like in a binomial. So if you did 1 minus the probability of none, it would be 1 minus 0.6 to the 4th power. It says 4. If you did it the binomial way, yep.
Why is the 4 just touched 0.6 now?
Because it's 1 minus, like the probability that none of them drive 5 miles over the speed limit is the complement, which is 0.6. 0.6 times 0.6 times 0.6 times 0.6. You do it 4 times. So that is this. And then you're subtracting it from 1 because it's the opposite of that.
Well, I know that.
If you did it the binomial way, so binomial is like 0, 1, 2, 3, 4. Like out of the 4 people, 0 of them could drive over the speed limit, 1, 2, 3, or 4. We want to encompass at least 1, so include 1, 2, 3, and 4. So you do 1 minus binom, CDF or PDF, it doesn't matter, either one, of 4.40. You want to subtract away 0. And you end up getting the same thing. So these two do the same thing.
That.
17. So normally distributed with a mean of 0.8, standard deviation of 0.25. and it's asking what the shaded area will be from 0.55 to 1.3. So if you have a normal curve where 0.8 is in the middle, I go up and down 3 standard deviations. It would be 1.05, 1.3, and then go down 0.55. So it goes minus 1 standard deviation plus 2 standard deviations, which gives me A.
Ms. Arnold, are we on the problem sets? Does it have to be completed in one setting?
No.
So you can log out of lockdown browser, it'll save it.
You just don't.
Mhm.
don't-
even have to go to lockdown.
Oh, you can come back.
No,
and resume.
it's not on Lockdown Browser.
Or it's not?
No, I took it off.
Oh, the second one will be, okay.
So in case you needed to look at the PDF.
Ah.
18, it has a positive correlation. So you can get rid of the like D and E. And then like there was a higher density for students, then the parents were kind of all over the place. So students tended to score higher. Yep.
Where is the higher density?
Like the first student, like the lowest score that a student gives is a 4, but most are in the like 6 to 9 range. You kind of see it like they're shifted over on the x-axis, but then the y-axis, it's kind of like all over the place. It starts at 2 and goes all the way to 10. Does that make sense?
Mhm.
So students tended to give higher scores, even though they're both, it is a positive correlation. Okay, this one was just being able to read and decide what kind of test it was and plug into the equation.
I'm sure it's A.
Oh, that's the population.
Not that one.
The N is the sample size.
Crazy fool.
I was also a fool.
I was also.
Oh, y'all do not do that. Mm-mm.
Yes.
Sample. Sample. That's foolish if you did 12,000. You won't make that mistake ever again.
That would be unfortunate. I messed up on the confidence interval one. We would spend 5 minutes on each class.
Okay, number 20.
That'd be kinda sad.
It's deciding what kind of test it was. It's a chi-square because why? What are some keywords?
Categories.
Categories. Where does it say category?
Twice. Bottom
It
line.
says it twice. Here. Categories, chi-square. Automatically. Then, so I'm going to get rid of A, B, and E. Now I need to decide what's the difference between an independence or an association test and a goodness of fit.
The amount
Sample
of
size and the variable.
The variable, they both are one sample, but this has 2 variables and this only has 1
Wait,
variable.
what are the variables for this?
And so let's decide, am I only measuring one thing? Like, am I asking my sample 1 question or am I asking them 2?
You're asking them.
I'm,
What?
Many services.
I'm asking them 1 question and they're going into 1 of 10 categories, like what
So-
maintenance that they need.
Is that one variable with many categories?
Yeah,
Like,
so
what
it
is
would be
that?
like, here's my list of, and then here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 types of maintenance issues that your house could have. But my, like, variable is maintenance issue. And then I have a maintenance issue of my trash needs to be picked up and I need to mow the lawn.
Like ice cream flavors variable, but they're like 10 times ice.
Uh-huh, exactly. $21 is D. So even though they gave you like 2 categories, it was just you're only wanting to measure
One random.
1 of them. Yeah, I only had 1 random sample. I didn't have 2.
So even when it's split into like group into male and female, is that one sample?
It'll say it in the problem whether it's 1 or 2 samples.
So why does it not matter that less than 10% were sampled?
So we want this to happen. This is a good thing. That's one of the conditions that we check. So this would not make it invalid. This would actually make it valid.
We want more than 30, but less than.
So for proportions, my conditions are random, NP and 1 minus P are greater than 10, and that makes it normal. And then my third condition is sample less than 10% of population. So these are the three that I check. And I want these three things to happen. So B is not correct because it doesn't make it invalid. It actually is a good thing that my sample is less than 10% of the population. (22) I hope that most of you got this one. So we're comparing the medians. The median is less for the unfertilized than the median for the fertilized. And then the IQR, which is this box, is greater for the unfertilized. So it should be D. Okay, I like this one. So 17% are enrolled in psych. So the probability of psych is 0.17. The probability of foreign language is 0.28. And the probability of psych or
This one was bad.
17
psych
plus
or
30
what is it, the other one? Foreign language is 32%. So you're just using the formula like probability of psych plus probability of foreign language minus both equals either or equals or. So you could say minus and if that helps. So what's the probability that I'm trying to find and? So I'm going to do 0.17 plus 0.28 minus the and, or minus x, equals 0.32. And you end up getting 0.13, I think. Yeah. Because this combines to be 0.45 minus x equals 0.32. So x equals 0.13. (24) Okay, this right here.
I'll get you.
This one is gonna get you right here, and I guarantee you, I'm like almost 100% confident this will show up on the AP test. Like 99% confident. Anytime it asks you to interpret the level, write this down, level. So confidence level. Your answer will never have the actual numbers in it. It won't have these numbers in it, the 815 and the 825. So go ahead and even like cross those out. Because it has nothing to do with the 815 and the 825, and it has everything to do with the 95. So what this means is the answer is C, and that's kind of the script that I want you to memorize. So if you had repeated sampling, if everyone in this class took a different sample, they went to a different city in Texas and they took a sample of 100 people, and you each created your own confidence interval that was unique and different from everyone else in here. Repeated sampling. Our intervals, our 95% intervals, would contain the population parameter. So here, the population mean 95% of the time. The key word here is that you use the word population. So that's why D is wrong, because it uses the word sample. And you're going to actually capture that population number 95% of the time. It goes up if you have a higher confidence level. That is if you're interpreting the level, not the interval. Okay. Next one. This one was one that we just talked about in Unit 15. confidence interval formula. Does anyone remember it for bivariate or for computer output data? You use these numbers, remember? What is this number? The 1.096.
Oh, that's the something star.
It's a slope.
Slope?
Just kidding.
And what's the number next to it?
The SB.
Yep. So formula for, and this one is not on the formula chart, confidence interval. B plus or minus T star SB. So I need the numbers 1.096, get rid of E, and I need the 0.1308. Get rid of those. Just A. I don't even have to calculate T star because they're all the same all the way down. So C and D, there has nothing to do with sample size when you're talking about confidence intervals and test statistics for bivariate data. What's the test statistic formula? T equals what? You remember?
SB over B.
Other way around. B over SB. Yeah. You do need to memorize these two. They're not on the formula chart.
Oh no. Dear. B plus or minus.
If anyone's curious, Bill Cosby just got convicted.
Of what?
Why?
What did he do?
Bad things.
Lots of.
He finally got convicted.
What bad thing?
Dirty.
He was a good
27.
That is false.
27. I think this one was a doozy for a lot of people.
Yes, this one totally.
The answer is C. Let's talk about it.
I was thoroughly duzed when this.
Let's talk about it. So I'm going to give you the equivalent in this classroom. So if I said, I want everyone to stand where I am standing, and I want you to try and measure the distance to the back wall. And none of us know the actual distance. We're trying to guesstimate it. So each one of us takes a stab at it, and then we find the average of all of our numbers combined. That's going to give us as accurate of a reading as possible because we don't know the actual distance. So when it says, which of the following is not a justification, the answer is C because it says the actual distance should be considered a variable. Well, if we knew the actual distance, we wouldn't run the test in the first place. The whole reason why we're doing this test is to try and guess the actual distance. So we cannot use the actual distance as a variable. All other four of these are justifications of why we should do this.
Oh,
Who's MacBook 560?
I do not know. If you know, let me know.
So
28. So this is another example of a chi-square test. And what kind of chi-square test is it? It tells us in the problem. Right here. Homogeneity. And homogeneity, the null hypothesis is what? It's just in our own words. We're saying that the proportions are the same for what?
Are they at the same?
All. What is it?
All the samples that I took.
Okay.
Oh, samples.
So I need to choose an answer choice that says proportions are the same for all samples. So I'm going to get rid of B. It doesn't matter. 110 is big enough. The sample sizes don't have to be equal. Going to skip D. And E doesn't matter. So I now I have A and D. The difference between A and D is that A is comparing the color scheme, but D is comparing the men and women. And the whole goal of homogeneity is we're trying to compare the samples. So we choose D.
What if it says? Not anymore.
Like we're wanting to compare the genders within the color preferences, not compare the color preferences.
Oh.
29.
Yeah.
29 is talking about the Z. It wants you to find the Z score because that's when it's talking about percentile. So, Aaliyah, her height is 0.96 standard deviations above the mean, and her friend Jane is within the 93rd percentile. So if you're 0.96 standard deviations above average, you're about 1 standard deviation above the mean. What if this is the 50th percentile? What is 1 standard deviation above? What percentile is that?
84.
84. And that's just using the empirical rule. What is a way that you could do it using your calculator if you forgot the empirical rule?
I tried.
The norm inverse with percentage.
Normal CDF.
Oh, yeah.
I thought if it gives you a percentage, you do.
If you did normal CDF, you could do negative infinity to 0.96, 0, and 1. And that would give you like what percentile you were, like what point you would be at. Because it's going to give you all this shaded area, which you end up getting like 80.83.
Oh, because the 0.96 of the standard deviation, that's her height, right?
Mm-hmm. So it's going to be either D or E. And if you're at the 83rd percentile and your friend's at the 93rd, then you're shorter. So D. 30. I liked this one. It's asking about the proportion above or below the mean. So I'm just going to try and guess where the means would be on each histogram. So on J, it's a right skew, so it's going to go to the right. On K, it's a left skew, so it's going to be on the left. And then on L, it's symmetrical, so it's going to be in the middle. So if I'm just coloring to the right because it's all talking about the proportion above the mean. So if I'm ordering it from least to greatest, it would be J, L, and then K. Because it's proportion above the mean. Oh. Let's see.
99 cards.
I don't know. Which of the following can be concluded? So, we can say that there is an association but not a causal relationship because correlation does not imply
Correlation.
causation. These two are saying the same thing, so that's why this one is not correct. This is not a true statement. It should be positive. Causes is bad. Because correlation and association are technically like the same thing. So
Why is it number 8E?
number 8.
I'm not clear, it's like 2 semesters.
Oh yeah, good times. 32. Oh man, this one.
Oh, yeah.
So you're finding the residual. You're wanting to find the actual. So residual equals actual minus predicted. I can look at the chart, go to 4, go up. My residual is 2 for 4. So 2 equals, I don't know what my actual is, I'm going to call it A, minus. I can calculate the predicted using my LSRL, which would be 10.53 plus 0.53 times 4, because I'm just plugging that in for X. And you end up getting 13 when you do that. So actual is going to be 2 plus 13, which is 15.
So wait, where did you got the 4 just because that's the...
So it's saying, like, what is the actual for 4 students in the backpack? So, or 4 books in the backpack. Not 4 students in the backpack. Just pop out. So I'm using, like, X equals 4 as my predicted and my actual. So I go up to 4. Here's my residual. My residual is 2. And so that means that my actual is 2 above the predicted. My predicted is 13, so that means I have 15.
That is a tricky one.
Yes. 33. Why do we stratify?
Not to reduce bias when estimating the least median time.
So it's to reduce variability. So we're going to get rid of A, B, and C because stratification doesn't remove bias or reduce it. It decreases variability. But then we're talking about mean commuting time, not proportion. of adults working in the areas. 34. Which of the following should guide the formation of the blocks? So what should I block by?
How it reacts to something.
Gender.
I should block by
Always block.
people that easily get sunburned.
Eliminate confounding variables.
So if you're in the same block, you're going to get all of the treatments. So choose an answer choice that you're blocking by similar characteristics. It's the same thing, but stratified. Stratified goes with observational studies. And then blocking goes with experiments. So they are the same thing, just using different wordage or vocabulary. Stratification is observational, blocking is experiments, but they do the same thing. 35. So it gives you 0.0853. So that means it's either less than 0.1 or greater than 0.05. So that leaves all of my answer choices there. If it's a less than, then I would reject, and if it's a greater than, I would fail to reject. So then I can go ahead and get rid of C and D, because it's saying it can be concluded that it's greater than or less than, so that's wrong. From there, B, it cannot be concluded. That would be wrong because we would want to reject. So I'm down to A and E. A is saying that it can be concluded that the mean number of text messages is less than 100. And then E is saying that it cannot be concluded that it's greater than 100. So now I need to decide what is the tail of the test. Like, am I doing a greater than or a less than test? So what is this? What is the question asking? Is it a greater than or less than test? Greater than. It tells me in the problem. So I would choose E. So while A is a true statement, that's not what I'm trying to test. 36. This one was also a doozy.
That was a definite doozy.
Okay, let's talk about this one.
Supremely doozed.
Expected number of weeks in a 52-week year that their combined donation will exceed $120. So I want to combine the mean and the standard deviations using the formula we did in the beginning. How do I combine means?
You add them.
Add them. So 30 plus 60 is 90. How do I combine standard deviations? So square root of 10 squared plus 20 squared, which is the square root of 500.
Which is
Something.
not 25.
I do not know. Now, I want to find the probability that, so now I want to find the probability that I exceed 120. The probability that x is greater than 120. And I do that by using normal CDF, 120 to infinity, 90, square root of 500. So someone do that and tell me what you get. Well, hold on. We'll do that in a second. Because we'll take this number and we'll multiply it by 52.
Let me get out my Inspire and I will do it.
Series. They take initiative.
I think you get like 0.1 something because it's about 10%.
Wait,
0.1 something.
Missing?
It's taking too long. Times 52, and you end up getting like about 5. So the answer is 5 weeks. I don't know what this is. You get something. I'm going to move on though. That is the steps that you do. So once you get the probability, what is it?
0.089856.
Okay. Once you get that probability, you're going to multiply it by the 52 weeks. And that's how you get,
where it came in.
yes,
That one foiled me.
it did.
Drat.
Okay, increasing the power, how do we do that? There's several ways.
Increase the difference between probability
So you increase the difference between ho and ha,
Increase the N.
increase sample size, increase alpha. So here we want to choose the one with the largest sample size. So get rid of A, B, and D. Now, my null hypothesis is 20%. And out of 25 and 50, which one is the furthest away from 20? 50. So E. This one was the doozy, 38. This one was the doozy of all doozies.
This one?
Yes.
No, 28 was the hardest one.
If you think of an easier way to do this one, then please enlighten me, but here's how I solved it. So, you have sums of, like, all the way from 2 to 12. And if you have a sum of 2, it's 1 and 1. I'm going to write them all out, because I don't know how to do this any other way. I wish I did. I do not. If you have a sum of 3, it's either 1 and 2 or 2 and 1. If you have a sum of 4, 1, 3, 2, 2, 3, 1. If I'm leaving any off, please help me. 1, 4, 2, 3, 3, 2, 4, 1, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. And then I don't think you need any more after that. Do you? No. And then the whole thing is out of 36 because there's 36 possible outcomes. So it says, what is the probability that the sum will be 4 given that the sum is less than or equal to 6? So I want to take the probability of 4 over the probability of less than or equal to 6.
Wait, could you just? I just found the number of, in the sample that were 3. I circled like the 1 and 3, 2 and 3, and 3 and 3. And I put over 15.
Yes. Well, that's what I think that's what I'm about to do.
Okay.
So here's my, I guess you don't technically need the 36. Here is my sample space, I guess, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 options. So my denominator is 15. The probability that it will be 4 is 3. So that's how you get 3 out of 15. I think why I thought it was hard is because you have to draw, for me, I had to draw out all the options.
Yeah. There's like it's like the head and tail.
Yeah.
All the heads and that's. No, all that.
39.
That's true.
What kind of test is this? Is there a significant difference in the average test score of talkative and quiet children? Then I can get rid of A, B, and E. Because difference in the means is what I'm trying to figure out. So if I'm between match pairs and 2 sample, how do I tell the difference?
You look and just see if it's matched to.
If there's a before.
How are the, yeah, so
Before and after.
samples for match pairs are either one sample getting 2 treatments or they're dependent samples. Whoops. Need to write this next match pairs. They're dependent. If it's just 2 sample, they're independent samples. So in other words, if this were a matched pair, then person 1 would be matched with person 1 in the second group, and person 2 would be matched with person 2 in the second group. Does it look like that's how the groups are being settled? No. So they're independent, so it would be just 2 sample T. Okay, last one, then we're done. Which assumption is necessary for confidence intervals to be valid?
Normal.
Distribution is approximately normally distributed.
Perfect. That was probably a good one to end on, right? Everyone remembered that one?
Oh my gosh, guys. Very important.